Hi guys, this is Andre again. Today I've got some updates on sound. Something I have neglected for quite a while, but now I have some exciting updates. Stay tuned. In my previous videos, you may have noticed that here we have an audio connector. And this is specifically for the Ulra-CPU board right now. I have a new microped version in the works that also uses FPGA and has all that stuff from this Ulra-CPU version included. But I can show it for you only here now. So, and if we add a little audio speaker, I should actually switch the machine on. So now let's run a small program that shows the audio capabilities. This is a small basic program. It loads a small machine code program, and then it opens a file for reading. Let's start maybe with this one, and then calls the machine code program to run it. It takes a while to load. This has loaded 8 kilobytes of music from disk into memory, and then it has started the DMA that sends the data to the DAC. The DAC is a very little small chip here. It's connected to the FPGA by SPI, and it has a separate SPI channel so that it's undisturbed by any activity going on the SD card or whatnot. If you look at the chip and the DMA register, we see the following. This is I use the MCP4802, which is a 2-channel digital audio converter, digital analog converter, and I have built a DMA engine that sends the data to this DAC in very controlled intervals. The DMA engine has a 16-byte buffer that is filled from memory as soon as there is bandwidth available from the video RAM. Because the FPGA can only access the video RAM right now, so it takes the audio data from there and puts it into the CPU byte buffer. And the reason I use that byte buffer is because, of course, we have video going on and so on, and using a 16-byte buffer gives us enough space or time in between fetches that we can load video data and send it to the video signal. The registers for the DMA are very simple. You have the base address, you have the length of the file that needs to be, or the length of the data that needs to be sent to the DAC chip. There is a DMA rate, which is counted in 1/64th parts of the main clock, which is 50 megahertz right now. I'll have an update later, and then there's a high rate, and then you can also send data to the channel directly, but not when DMA is working. So you can also control all this with the CPU. On read, you see the last byte that has been sent to the DAC, and as I said, this is a 2-channel DAC, so we have channels 0 and 1. So when you look at the status register, we have DMA is active, so it's sending and fetching data to the DAC. Bit 6 is if the interrupt has occurred, and the interrupt occurs when all the data has been fetched into the buffer. And you can see that on bit 5, when the DMA has fetched all the bytes but the buffer is not empty yet and data is being sent out to the DAC. This is the signal. Now you can rewrite and change the DMA registers like address and so on, and restart the DMA. And then automatically the buffer will be filled from that new location. So you can have an interrupt before the last 16 bytes are being sent to the DAC. And then you can ensure that you have uninterrupted DAC output via DMA. There's a control register. This is the interrupt enable, as I said, when all the DMA, all the data has been fetched into the buffer, even though the SPI transfer to the DAC is not yet finished. Then we have if we have two modes, we have mono or stereo mode. So in stereo mode, the data needs to be doubled, and there's 1 byte for channel 1 and for left, and then the byte for channel right, for the right channel. If we don't do stereo, the bit 3 indicates that which channel should output the data. So if we're in mono, we can do it on the left channel or on the right channel. But we can also use the dual mono flag. We set the stereo, and then we also set this bit 3 dual mono flag. Then we only have 1 byte of data, but it's sent to both channels. Very nice. There's a loop flag. If the DMA block has been read till the end, it automatically starts from the beginning. And here you can just start the DMA. Once we've loaded the file, you can also control it with a poke, because the DMA address, start address and so on is reset to the original value. And because you may have noticed this is a mono plug. The next version will have a stereo plug, but here's only one channel that goes out to the speaker. So, and it's not the channel 0, so it's channel 1. I have to add this 8 here, and then you get the same sound again. And then I could go to stereo, and if I add the dual mono flag, nothing will change, because both speakers will get the same data, so you don't see any or hear anything different. And if I do a true stereo, then you'll notice that the speed is twice as fast, because every second byte goes to one channel, not goes to the other channel. And I don't know why that beeping sound came from, where that came from right now, so I'll have to see what this is. Now I have some other exciting news, because there's this board here. And as you can see, this has 2 ARM SIDs, or the capability to use 2 SID chips on that bus system. Here actually there is a 9 volt voltage generation. So currently you have to change some components, but it's 9 volt currently. You could use the 8580 SIDs, not the 6581, because they need 12 volts. There's 2 kinds of mixers that I tried. So what I'm going to use is this one. Here you can also see there's already a stereo plugin. This cable we can connect to the board here. So as you see, I've connected this cable here. I've switched the speaker to this kind of mixer, and then you can also run So it's loading again. And now you can actually also see that's also coming on the second channel, because both channels here are connected. So with the SID we can also have SID files. I modified a small player. And there you have it. So, and now to the final part of this update. I have changed the boards. So you've seen here, this is the board I had in before with the mono plug, and this was using Spartan 3 FPGA. This one is an updated version, and this is going to be the base for all the upcoming boards. So it has a Spartan 6, which is faster. It has a stereo plug. Otherwise, not much has changed, but if you look at the screen, if you look at this, you can see you suddenly have a border. And a left and right border at that. And the reason for that is because this board is running not at 50 MHz, but at 70 MHz. And this means this is not a 640 by 480 VGA resolution, but a 768 by 5 something. So we actually now have a real border. I haven't managed to get a real demo about that yet, but if you run the old demo, you can see it still works. There are some artifacts there yet. This line below here, the sprite is not yet working correctly. And this is using absolute coordinates. The absolute coordinates are here on the left top window. But we do have that border, and we have that at the back. And you can see the sprite is going outside the border with just the single bit flip and no opening border magic required. So yeah, I'll be working on that some more, and we'll have you updated in a follow-up video. So thanks for watching, and see you next time. Oops. So this has loaded 8 kilobytes from memory, from disk into memory. So this has loaded 8 kilobytes from disk into memory, and then started the DAC. And there you have it.